Alright, so regarding the video I made yesterday, I did find somebody that almost addresses the problem, but totally doesn't address it at all at the same exact time. Okay? So here we have this page that sets gives us an idea of the sets. It sets up the sets. And you might note the paradoxes that are involved here, right? So the natural numbers are the counting numbers, 1, 2, 3, etc., are the positive integers, or the whole numbers, 0, 1, 2, 3, right? The non-negative integers, so 0 may or may not be in there. Okay, already that's stupid as fuck. Why can't you make a goddamn decision about this? They are different from each other. Use different fucking names, you goddamn morons. And then mathematicians use natural for both cases, natural numbers. Anyway, okay. That'll come back to us in a little bit. 0, as noted, is the problem all along. So, should nip it in the bud. Take care of it at this stage. But whatever. We'll carry on. Alright, integers are the natural numbers and their negatives, yada yada. And because of course it's a Z because of German. Because everybody loves Germans. That's just, I don't understand why that's true, but whatever. Rational numbers are the ratios of integers, or the fractions. Note that that's not true, because 0 is an integer, and you can't really get viable ratios if 0 is in either the numerator or the denominator. If it's in the numerator, you don't get a ratio, you always just get 0. That's not a ratio. If it's in the denominator, it's undefinable. That's not a ratio either. Further, any ratio should be invertible to get something back, and if 0 is in either position and you invert it, you get the other one. That neither of them makes sense. One loses the unit, the other loses the value, the number part. So, no, already, so that's wrong. It's not the ratio of integers, okay? And again, the problem is 0. Alright, real algebraics, yada yada, I don't really care. The reals, yada yada. Okay, so, what is it called? The complement of the rationals is the irrationals. And the complement of the algebraics within the reals is the transcendentals. Okay, we're good. We're good with that. Alright, so here we go. We've got the real number line, yada yada, naturals. 0 may be included, so 0 may or may not actually be in this. But they include it here in the naturals, in this version of it. Okay. Now here we've got 0 included in the naturals, and we have this containment hierarchy, and we can see that we have a complement to the rationals, we have a complement to the real algebraics, but in here we don't have a complement to the integers, and we don't have, and within the reals we don't have a complement to the integers, and we don't have a complement to the naturals within the reals or the algebraics or the rationals or the, so like, okay, why isn't that gap between the rationals that are not integers, why isn't that a named category? Right? So there's definitely some missing things in here. Alright, now let's go over to the complex numbers. Okay, so imaginary numbers are numbers whose squares are negative. Okay, they are the square root of -1, and all real multiples of I, such as 2i and I root 2. Notice, 0 is not negative. By definition up here, 0, if 0 is a whole number, it's non-negative. Okay? Square root of 0 is 0. So by this definition, 0 cannot be an imaginary number. Okay? Problem with that is once you get to the complex numbers, if you want to say that the reals are complex numbers with an imaginary part of 0, then you have to say that 0 is an imaginary number. So you've contradicted yourself here. Okay? Now we have the complex number plane. 0, it looks like 0 is a complex number. It's part of this axis here. And 0 is a real number. Okay? Now down here, we get a diagram where 0 is imaginary, 0 is real, but now 0 is not a natural number. Okay? So they've contradicted themselves there. And this is also fun. This is an Euler diagram, not a Venn diagram. Ignoring the fact that Venn diagrams are a type of Euler diagram. So that claim is, again, like, we're not being careful about what we're talking about. Okay? Like, you see the problem? This doesn't actually make sense. There is a complete lack of rigor here. What in the fuck? What in the fuck? Is 0 natural or not? Sometimes, here, we're saying that it is. Here, we're saying that it is. Here, we're saying that it's not. Or are we saying that it is? Does it include, is it this whole thing? Maybe. I don't know. But you also have these notes, like 0 may be included. So this implies that we're assuming it's not, but it could be. But you drew it as if you're assuming that it is. And then you're, like, the words don't match. What the fuck? This is so fucked. And people wonder why students have trouble learning math. You say stupid fucking shit. If imaginary numbers are numbers whose squares are negative, then the square root, right, all real number multiples of I, which would include 0i, what is the square root of 0i? It's 0. What is our definition of 0? It's non-negative. So that can't be imaginary if we put these together. That doesn't make any sense. But it has to be imaginary, and down here you're claiming that it's imaginary. What in the fuck? What in the fuck? And there's no actual mention, really, of 0 at all. There's just like, we just breeze past it. Like, yeah, it's a number, so it acts like everything else. It's the source of all of the problems here, but nobody cares. Why? Why? What in the hell is going on? Why is this so stupidly broken?